All right, so today we're going to look at graphs of rational functions. What are rational functions? Well, they are fractions where you have a function over the top of another function. Okay, so we have fractions. So if we're asked to find the domain of this rational function, the domain depends on the denominator. You cannot have a negative inside a square root, and you cannot have a zero in the denominator. What would make this denominator zero? So the domain on this is all real numbers except for negative 2, which in interval notation is negative infinity to negative 2 in union with negative 2 to infinity. Now, why did I use parentheses instead of brackets around the 2? Because it can't be negative 2. Okay? So it does not include a negative 2. So make sure you use just parentheses there. Okay, if we look at the graph, we see there's, what do we call this line that looks like this? An asymptote. There's a vertical asymptote. As you go towards that asymptote from the right, you're going towards infinity. From the left, you're going towards negative infinity. So as you approach that line from the left, you go down. As you approach it from the right, you're going up. Okay? That's a calculus thing. That's how we start out the year in calculus. The first couple weeks of calculus is looking at those limits and things like that. Okay? All right. Here, you cannot have 0 in the denominator, so the domain is everything but 0. And our range is everything but 0 because we have not only a vertical asymptote, but we have a horizontal asymptote. Okay? So the range goes from negative infinity up to 0 and 0 to infinity. Is it continuous? Well, no, it's not continuous. It's continuous from negative infinity to 0 and from 0 to infinity, but it's not continuous on all x's. It's decreasing everywhere except for at 0. It is an odd function. Why is it an odd function? Well, if you flip it over the y-axis and then the x-axis, it maps onto itself. So if it does that, it's an odd function. So it has a horizontal asymptote, vertical asymptote, and so on. So looking at these, this problem here, if we graph it, what's negative 2 times 1? So at an x value of 1, we're at negative 2. What's negative 2 divided by 2? Negative 1. So it's going to be a function that looks like this. And it's an odd function, so it's going to look like this. Okay? So if we look at this, here's the sketch of the function. Does it have a vertical asymptote? Yes, at x equals 0. Does it have a horizontal asymptote? Yes, at y equals 0. What is the domain? Well, it's negative infinity to 0, 0 to infinity. Range, same thing, negative infinity to 0, 0 to infinity. Okay. So as we approach 0 from the left, where is it going? Infinity. As we approach 0 from the right, where is it going? Negative infinity. Now, what's our vertical asymptote on this one? Negative 3, right? Negative 3. So we just take this graph and move it over 3 to the left. 1, 2, 3 to the left. There's our vertical asymptote. We have a horizontal asymptote. Since there's a negative in front, it's like this and like this. Okay? So for this one, our domain is negative infinity to negative 3. and negative 3 to infinity. Our range is negative infinity to 0 and 0 to infinity, because our range is the y values, so our horizontal asymptote is still at 0. We have a vertical asymptote at negative 3, horizontal asymptote at 0. Yeah. And then this one is a little more complicated. Okay. This one has a vertical asymptote at negative 3, but its horizontal asymptote is not at 0. It's actually got a horizontal asymptote at 2. Okay, up here at 2. Why? Well, what happens is when we have 2x over x, and those are the highest powers each, we take the coefficients of each of these and divide to figure out where the horizontal asymptote is. So our horizontal asymptote is at 2. Our vertical asymptote is at x equals negative 3, and this is y equals 2. And if I want to test, put in a 0 here, I get 0 4/3, which is down here. 0 4/3 is down there. If I go like negative 2, I get negative 4 plus 4 is 0. So it's like this. So it must go like this, just like the other ones. Okay, because if we go negative 5, I get negative 10 over negative 2, which is positive 5. So yeah, looks like that. Okay. All right, asymptotes. Where are our vertical asymptotes? X equals negative 1 and x equals negative 5. You get vertical asymptotes from the denominator. What are our horizontal asymptotes? Well, if we multiply this out, this would be x squared plus yada in the bottom. On the top, it'd be 2 times x squared minus 9. And then 2 times x squared is 2x squared over x squared. So what's our horizontal asymptote? 2. Horizontal asymptote is y equals 2. Intercepts of the function. Your x-intercepts come from the numerator. So x plus 3 equals 0, x minus 3 equals 0. So x equals negative 3 and 3. Those are our two x-intercepts. If you want to put them as ordered pairs, it'd be negative 3, 0, and 3, 0. How do we find our y-intercepts? Well, to have a y-intercept, your x value has to be what? 0. So you put in 0 everywhere there's an x. So for your y-intercept, it's going to be 0 something. Well, if we put in a 0 here, a 0 here, a 0 here, and 0 here, it's 2 times 3, which is 6, times negative 3, which is negative 18, over 1 times 5 is 5. So it's negative 18 fifths is our y-intercept. Okay. So our asymptotes happened at negative 5 and negative 1. And then we had a horizontal asymptote at 18 fifths, which is 3 and 2 fifths. So about right here. Now, notice this blue line. It crosses the horizontal asymptote. You can cross a horizontal asymptote. You can never cross a vertical asymptote. But you can cross a horizontal asymptote. But horizontal asymptotes are, as you go out towards infinity, what's it getting closer to? Well, it's getting closer to that negative 18, or that 18 fifths. And as you're going towards negative infinity, it's getting closer to that 18 fifths, that y equals 18/5. Okay. This function, what is our vertical asymptotes? It has two of them, x equals 2 and -3. Horizontal asymptote. Now, on the top, it's x minus 1. On the bottom, it's x squared plus x minus 6 is what it winds up to be. These aren't the same power, so you don't use the coefficients. If the power on the top is smaller than the power on the bottom, then your horizontal asymptote is y equals 0. If your power on the top is higher than your power on the bottom, then there's no horizontal asymptote. If your power on the top is higher than your power on the bottom, then there's no horizontal asymptote. So in this case, your horizontal asymptote is y equals 0, because your power on the top is lower than your power on the bottom. Do we have any x-intercepts? Well, what makes the numerator 0? 1. So 1, 0 is our x-intercept. Do we have any y-intercepts? Well, yep. Unless we have a vertical asymptote at 0, we're going to have a y-intercept. Always, always, always. It's going to be 0 what? Well, on the top, I have -1. On the bottom, I have -6. -1 divided by -6 is a positive 1/6. All right. So quickly looking over the problems, I'm not really going to get into them too much because we've already done enough of them. You'll have to say what the domain is. So x cannot equal a -5. And then for part B, since x plus 5 would be looking like this, as you go towards -5 from the left, you're going down to negative infinity. As you're going towards -5 from the right, you're going up to infinity. Okay. Kind of the same deal with some of these. I kind of went over most of this to the as you're going towards 4 from the left is what it's talking about. Well, 4 is where this asymptote is. As you're coming to it from the left, you're going towards infinity, and so on. So your 7 questions will look like that. The first 3 will be a little bit tougher than your other ones. Okay, so I'll let you get going with that. If you have questions, you can ask. I'll help you out.